Okie doke. So in this video we're going to be looking at solving exponential equations. So what I mean by that is when you have an equation but the unknown is part of a power. So there's a nice simple 1. So I've got 3 to the power of x equals 20. So whenever we see that, and I'm going to do a few more examples here just to work through the different types, but whenever we see the unknown is either the power or there's a function of x as the power, we take logs. Okay, so let's do that. Let's take logs. So in the same way, when we're solving equations, we can do the same thing to both sides. We can take logs to both sides. So I've got log of that equals log of that. Using my power of logs, I can bring my x down to the front. I'm using log base 10 because that's the button that's nice and convenient for me on the calculator. And when I use log base 10, I don't need to write the 10 in. If you do, it's fine, but no need to at all. So I've got x log 3 equals log 20. So log 3 is just a number. It is log of 3. If you type log of 3 into a calculator, you will get a number. So we can divide by it. So we divide both sides by log base 3, and we get x equals log 20 over log 3. And that goes into our calculator. So advice here is to use the fractions button. So I've got log 20, I've got log 3, and I get my answer. I will do it to 3 significant figures, 2.73. Okay. Next example. If you want to have a go, if you want to pause and have a go at these before I do them, by all means do. Try and get them in focus. There we go. Okay, so this time something very similar, but this time it's not 5 to the power of x, it's 5 to the power of a function of x, so 5 to the power of 2x plus 1, but the process is the same. Now I've got log of 5 to the power of 2x plus 1, so 5 is the power of 2x plus 1, so I can bring my power down. Now I'll just make the most common mistake that I see, just to discuss that. So I've written that is the most common thing that I see going wrong with this. We must put brackets around that because it's the whole of log 5. Log 5 is being multiplied by the whole of 2x plus 1, so we have that. So we can now start simplifying. So I've got 2x log 5 plus log 5. I've expanded that bracket out over log 3. So I've got 2x log 5 equals log 3 minus log 5. So x, if I divide through by 2 log 5, I end up with log 3 minus log 5, all divided by 2 log 5. Straight into the calculator, just like that. If you're not someone who uses the fractions button, do. It saves all sorts of problems and errors, but that can go straight in the calculator just like that. We don't need to work out each one individually and then use the numbers. So I've got x is equal to minus 0.159 to 3 significant figures. Okay. Third example. So we'll just sort of raise the complexity a little bit. Actually, the method is the same. It's not really an issue with the logs. It'll just come to an issue with algebraic manipulation. So this time I've got the unknown is a power, but this time I've got an x here and I've got an x over here. So let's deal with that. Exactly the same as before, it's just happening to both sides this time. So I'm going to expand and simplify. So if I take, well, let's expand first. I'm going to bring my x's to this one side. And the terms without an x to the other side. So that's going over there and this is coming over here. I'm going to factorise out my 3. And I'm going to divide through by that. And that is what can go straight into the calculator. Okay, so fractions button 2 log 3 minus log, oops, sorry, fractions button 2 log 3 minus and the answer is 0.297 to 3 significant figures. Okay. Okay, just a little bit of care and attention, a little bit of a fairly tricky algebraic manipulation, I suppose, but as long as you're careful, that won't go wrong. Okay, so let's look at one more type. So we see these fairly commonly, and if you know what to do, they can be fairly straightforward. So that is in fact a hidden quadratic, and actually it is a quadratic in 5 to the power of x, because 5 to the power of x squared is 5 to the power of 2x. So let's take a substitution method on this. So if I say y is equal to 5 to the power of x, then this equation here can be rewritten in terms of y. So 5 to the power of 2x is y squared, because y squared is going to be 5x all squared, which is 5 to the power of 2x. So I can write that as y squared plus 7 times y, because 5x is y, minus 30 equals 0. I can now solve that in terms of y, so we can put it into our calculator as a quadratic, or we can factorise and solve, whatever method we have to solve. So I'm going to take my 2 solutions, so actually y is equal to minus 10 and y is equal to 3. So those are the 2 solutions that I have. Now I'm being asked to find x and not y, so let's just think about these. So I'll do them separate. So let's deal with the minus 10 first of all. So if y equals minus 10, what we're actually saying is 5x equals minus 10. So if we think carefully about that, is there any number that could be? We take 5 to a power that I'm going to get a negative number. There's no number that can be, so there are no solutions to that. I think maybe one way of maybe thinking about that is think about the y equals 5 to the power of x graph and what it looks like, and it looks like that. It never goes below the x-axis. There are no negative values to it. So whenever we get something to a power equals negative, there are no solutions. So we can just write no solutions there. So let's deal with this one here. So I've got 5 to the power of x equals 3. So now this is very much like the same as the first example that we talked about. 5 equals log 3. So x is log 3 over log 5. And that is what is going to go in the calculator. Log 3 divided by log 5, and I get x equals 0.683 to 3 significant figures. Okay, I mean they can get a little bit more complex than that, but that's the basics, and as you can see it was the same approach on all of them. Well worth practicing. Okay, hope that was helpful.